Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, Crossing New Frontiers to Conquer Today's Challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
Thank you. I'm Philip Emeagwali. For 200,000 years, our ancestors counted only one thing at a time. The invention of parallel processing makes it possible for us to count a billion things at once and thus count a billion times faster. This new mathematical knowledge of how to compute faster is a paradigm shift of tectonic proportions. It's called massively parallel processing. Parallel processing is to mathematics what the theory of continental drift is to geology. Parallel processing is to physics what the theory of evolution is to biology. Parallel processing changed the way we look at the computer. In the field of computer science, the quintessential question is this: what is the grand challenge problem for computer science of the 21st century? My answer is this: the hardest challenge in computing is to invent a supercomputer that is several orders of magnitude faster than any existing supercomputer. And more importantly, to use that new supercomputer in a manner that makes the planet a better place for all beings. My contribution to the development of the computer is this: I discovered that by doing many things at once, 180 years on a computer can be speeded up to only one day on a supercomputer. My discovery of how to do many things at once opened the door to the modern supercomputer. My discovery of a new computer that can do many things at once opened the path to a new computer science. I discovered how to solve the toughest problems arising in physics and mathematics and solve them by solving a million problems at once. I invented the supercomputer that is a new internet de facto. For the next generation, their grand challenge will be to invent their internet as their planetary-sized supercomputer. How are supercomputers used? The parallel supercomputer of today will become the modern computer of tomorrow. Asking about the usefulness of the supercomputer that is an internet is like asking about the usefulness of the computer and the internet. That's like asking, what will the world be like without the parallel supercomputer? Without the parallel supercomputer, there will be no modern computer. A world without the parallel processing computer is a world in which 99 of the 100 processors inside your computer is turned off and you are programming at only 1% of your computer capacity and perhaps achieving only 1% of your productivity level. A world without the massively parallel supercomputer is a world in which fewer discoveries are made. It's a world in which innovation is slowed down. It's a world in which human progress is slowed down. And it's a world in which the computer of tomorrow cannot be invented today, and thus making it impossible for us to create the future. A new supercomputer that cannot parallel process across its 1 million processors is reduced to the stature of an ordinary computer that is powered by only one processor, that is not a member of an ensemble of processors. A new supercomputer that is not parallel processing is like New York City with only one street light on. The parallel supercomputer that will enshroud planet Earth as the internet of the future is where today's science fiction will become tomorrow's non-fiction. That planetary-sized supercomputer hopeful is where humanity's future will take shape. 1 in 10 parallel supercomputers are used to discover and recover otherwise elusive crude oil and natural gas. The remaining 9 in 10 supercomputers are used to solve real-world problems that are similar to extreme-scale general circulation models that are used to foresee otherwise unforeseeable global warming. The invention of the parallel supercomputer is the biggest advance in physics since Newton Galileo. In the decade of the 1980s, I conducted my parallel processing research alone, and I did so because it was a grand challenge problem that was over the heads of others. Inventing the 9 new partial differential equations that I solved across a new internet, that is a new global network of 65,536 processors, was out of the depth of any person whose full-time career was to teach mathematics or physics or computer science. It was clear from the vacant expressions on their faces that my explanations of how I emailed my 64,000 codes and data to and from each of my 65,536 processors was science fiction that went completely way over their heads. In 1989, I was the only full-time programmer of the most massively parallel supercomputer that ever existed. The parallel supercomputer was abandoned for only one reason, namely, it was over the heads of any of the 25,000 vector processing supercomputer scientists of the 1980s and earlier. Parallel processing increases productivity across gigantic industries, from healthcare to transportation, to finance, to business. It's impossible to construct a realistic physical model of atmospheric and oceanic circulations flowing across the surface of planet Earth. It's possible to conduct an extreme-scaled, high-resolution computational experiment that are parallel processed across an ensemble of millions upon millions of commodity off-the-shelf processors that shared nothing between each other, that were tightly coupled to each other, that were identical to each other.
Insightful and brilliant lecture.